All right, hey guys, it's me again. We are again looking at 9.4 questions on particular homework problems that you guys had. Get that cursor out of the way. You would think I would catch on and do that before I start recording. And right now we're looking at number 54 on section 9.4. Let's take a look at this one. Hopefully you caught the information above. There is a slightly different vertical motion model here because we're talking meters. The one that I gave you in class is if we're talking feet, but if we do change the unit here to the metric system to meters rather than feet, really, you notice the only thing changes is that negative 4.9 instead of negative 16. My guess, I'm not a Canadian or anything, but my guess that 16 feet is the same as 4.9 feet. Probably has something to do with that acceleration due to gravity. I don't know. Ask your science teacher. All I know is we've got this vertical motion model now for all our Canadian friends. Kicking a soccer ball, I think. So here's what's going on. We got a soccer ball that's kicked upward from the ground with an initial velocity of 3.6 meters per second, not feet per second. So the initial velocity is 3.6. How long is it going to take that soccer ball to hit the ground again? All right. So again, I fill in what I know. I want to know when is this thing going to hit the ground. All right. So that means height is 0. And it also means that the times, my t's are my variables. All right. I don't know what the time is. That's what I'm trying to figure out. This can still be negative 4.9, so it's negative 4.9. The initial position, we've talked about this in a couple other problems. Check those videos out. I'm not going to fill anything in because it was on the ground when it started. So its initial position would be plus 0. So I don't need to add that. Now we are going to get to some later where, all right, what if I hold the soccer ball and kick it and it's 2 feet off the ground when it leaves my feet? That's going to change some things. We're not talking about that just yet. On this one, it's leaving the ground, so S is 0. So the only thing I don't have is the initial velocity, which they told me was 3 6/10. So I'm going to fill that in there. All right. So I've got my formula. I've got my equation, and I'm ready to solve it. So it's equal to 0. That's taken care of for me. So now I need to factor it. And again, so I'm looking for common factors. I don't see anything jumping out at me between 4.9 and 3.6 as far as common factors, but I do see a t squared and a t. So I can factor out that t. Again, factoring out is the undistributive property. I'm really undistributing these things. We've done the distributive property. This is the undistributive property, or the distributive property backwards. So I can factor out a t, and then t times what would give me negative 4.9 t squared. That would be negative 4.9 t. And then t times what would give me 3.6 t, and that's going to be 3 6/10. All right. So now I've got it factored. I've got it written as a multiplication problem, and I've got it equal to 0. So now I'm ready to use the zero product property. Zero product property says if we multiply two things and get 0, then one of those two things has to be 0. So this says either t is 0 or negative 4.9t plus 3.6 is 0. One of those two equations has to be true. All right. Again, this one already solved for us, and that one makes sense because, again, we're answering when is this soccer ball going to be on the ground? Well, it's going to be on the ground Genesis 1:1 in the beginning. All right. So at the very beginning, before this thing is even kicked, or right at the instant we stop that or start that stopwatch, right at 0 seconds, this thing is on the ground. When is it going to hit the ground? Well, that's when it's going to come back down. So that's the equation we need to solve here. And this is, take a whiff. Yep, it's a 2-step. So I subtract. I do addition and subtraction first. I've been drawing my honking tonkin line. I apologize for that. So we have negative 4 9/10 t equals negative 3 6/10. Again, that's 4 9/10. There's a decimal point there. And there's also a decimal point there. Don't lose those. Kind of hard to see it on that board. But now I'm going to divide both sides by negative 4 9/10. And so if I do negative 3 6/10 divided by 4 9/10, I get, oh my gosh, big ugly decimal. So we're going to go 2 places past the decimal here, and I'm going to call it about 0 73/100 of a second. Okay, so it's not going to take this soccer ball long at all. Must not have been kicked very fast. 3.6 meters per second. Must not be very fast, but because less than a second later, again, there's a decimal point there. Don't lose that decimal point. That, takes less than a second for this soccer ball to come back down and hit the ground. So, all right, so this is 54. Again, vertical motion model, slightly different here because we were talking meters, but it's still fill in that initial velocity, factor it, take a look at both equations using the zero product property, and you should be good to go. All right, take care, guys.